Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Here begins the essay. The advent of the World Wide Web presented both unprecedented opportunity and significant technical challenges for information retrieval. Among the early contributions attempting to address these challenges, Larry Page and Sergey Brin's 1996 paper, The Anatomy of a Large-Scale Hypertextual Web Search Engine, stands as a particularly influential articulation of a novel approach. This essay undertakes a detailed, section-by-section analysis of this seminal work, critically evaluating its central claims and the supporting arguments presented. The aim is to provide a thorough assessment of the intellectual foundations upon which Google, as we know it, was built, examining the paper's lasting impacts and the inherent limitations. Section 1, Introduction and Motivation. The paper commences with a concise justification for its existence, asserting the inadequacy of existing search engines in scaling to meet the rapidly expanding web. Page and Brin identify several shortcomings, including problems with both relevance and computational efficiency. The initial claim is that AltaVista, at the time the dominant search engine, indexed a substantial fraction of the web, but that its reliance on keyword matching alone led to a proliferation of irrelevant results. This is a fair assessment of the state of web search in 1996. The authors suggest that a more sophisticated approach, leveraging the hypertextual structure of the web itself, could offer significant improvements. A key assertion lies in their belief that the link structure contains valuable implicit information about the quality and relevance of documents. Furthermore, the introduction emphasizes the practical experience gained from building a functional search engine, named BackRub, which prefigured the development of Google. This hands-on approach, they argue, allows for a more grounded evaluation of theoretical concepts. The claim that practical implementation informs theoretical understanding proves fundamental to the paper's credibility, lending weight to their subsequent arguments. Section 2, Related Work. This section provides a brief overview of existing information retrieval techniques and systems, placing BackRub within the context of previous research. Page and Brin acknowledge the contributions of established ranking algorithms like term frequency and verse document frequency, often written as TFIDF, and vector space models. They accurately portray how these methods primarily focus on the content of documents, overlooking the wealth of information embedded in hyperlinks. The section distinguishes BackRub by highlighting its emphasis on link analysis, differentiating it from purely content-based approaches. A specific claim concerns the limited impact of prior link analysis research on the design of real-world search engines. The authors suggest that existing link analysis techniques suffered from scalability issues or failed to adequately address the problem of spam and manipulation. This claim is somewhat contentious. While it is true that link analysis had not yet achieved widespread adoption in commercial search engines, several academic projects were actively exploring its potential. However, Page and Brin accurately pinpoint the lack of robust spam detection mechanisms as a significant barrier to its practical application. The section concludes with a subtle and important assertion that BackRub represents a more comprehensive and scalable implementation of link analysis than its predecessor. Section 3, System Overview and Architecture. This segment delves into the architectural design of BackRub, detailing the key components and their interactions. The authors present a schematic diagram illustrating the flow of data, from web crawling and indexing to query processing and result ranking. The explanation of the crawler, responsible for discovering and retrieving web pages, is relatively brief. The key claim here is that the crawler is designed to be both efficient and robust, capable of handling the inherent complexities of the web. However, the paper provides limited detail on the specific crawling strategies employed, such as politeness policies or duplicate detection mechanisms. The focus then shifts to the indexer, which parses the retrieved documents and extracts relevant information, including words and links. A significant assertion is the importance of storing the index in a compressed form to minimize storage requirements and improve query processing speed. This highlights a practical consideration often overlooked in purely theoretical discussions of information retrieval. The architecture section concludes with a description of the ranking module, which is responsible for computing a score for each document based on its content and link structure. The architecture is described as scalable and distributed, an implicit claim that it can handle the demands of indexing a substantial portion of the web. Section 4, PageRank Link Analysis Algorithm. This part forms the core of the paper, presenting a PageRank algorithm in detail. PageRank is described as a numerical weighting assigned to each web page, reflecting its importance within the overall hypertextual structure. The algorithm operates on the principle that important pages are likely to be linked by other important pages. The authors provide a mathematical formulation of page rank, iteratively calculating the score for each page based on the scores of pages. At link to it, the equation provided is the foundation for understanding how page rank functions. Let P sub I represent the page rank of page I. Let B sub I represent the set of pages linked to page I. Let L sub j represent the number of outbound links on page j. Then, page rank of page I equals the sum, over all pages j and B sub I, of the page rank of page j divided by L sub j. The introduction of a damping factor, typically set to 0.85, addresses the problem of rank leakage and ensures convergence. This damping factor, mathematically represented as a lowercase d, introduces a probability that a user, when at a given page, will instead jump to a random page. The authors claim that page rank offers several advantages over existing link analysis techniques. It is argued that page rank is less susceptible to spam and manipulation because it considers the entire link structure of the web rather than relying on simple inner link counts. Furthermore, the authors assert that PageRank provides a more global measure of importance, capturing the intrinsic value of a page rather than its popularity within a specific community. This claim regarding global importance is a crucial one, as it distinguishes PageRank from more localized link analysis methods. The section dedicates considerable attention to the computational efficiency of PageRank, highlighting the iterative nature of the algorithm and the techniques used to accelerate convergence. It states that the algorithm can be efficiently computed even for very large graphs, thanks to the sparseness of the web's link structure. This assertion regarding computational efficiency is borne out by the subsequent success of Google. Section 5. The Google Search Engine. This section describes the implementation of the Backrub search engine, now rebranded as Google, and presents experimental results to demonstrate its effectiveness. The authors provide details on the hardware infrastructure used to power Google, including the number of servers, the amount of storage, and the network bandwidth. They claim that Google is capable of indexing a significant portion of the web, surpassing the coverage of other search engines at the time. This claim is supported by statistics on the number of pages indexed and the number of queries processed per day. A key aspect of this section is the evaluation of Google's search quality. The authors present results from user studies and comparisons with other search engines, demonstrating that Google consistently provides more relevant and accurate results. They highlight the importance of combining PageRank with traditional content-based ranking techniques to achieve optimal performance. A crucial argument is that PageRank acts as a powerful filter, identifying high-quality pages that are then further ranked based on their content. The paper acknowledges the limitations of its evaluation methodology, noting the subjective nature of relevance judgments and the difficulty of comparing search engines in a controlled environment. However, the authors maintain that the experimental results provide strong evidence for the effectiveness of Google's approach. The inclusion of content-based ranking is seen implicitly as a key component in Google's and Backrub's operation. Section 6. Discussion and future work. This concluding section summarizes the key contributions of the paper and outlines potential directions for future research. The authors reiterate the importance of link analysis in web search, emphasizing the advantages of PageRank over existing techniques. They acknowledge the challenges of dealing with spam and manipulation, suggesting that further research is needed to develop more robust algorithms. A significant claim is that the combination of link analysis and content-based ranking represents a powerful approach to information retrieval. The authors propose several areas for future investigation, including improved crawling strategies, more sophisticated indexing techniques, and personalized search algorithms. They hint at the potential for using link analysis to identify communities and track the evolution of the web, showcasing the broader applications of their research. The section concludes with a hopeful outlook on the future of web search, suggesting that continued innovation is essential to meet the ever-evolving needs of users. This section effectively argues for the ongoing relevance of link analysis techniques in the face of new challenges. Section 7. Handling link spam. A particularly prescient aspect of the paper is its discussion on handling link spam, an issue that would become increasingly critical in the years following its publication. Page and Brin acknowledged the potential for malicious actors to manipulate PageRank by creating artificial links, thereby boosting the ranking of their own websites. They identified several strategies for combating link spam, including detecting and discounting links from suspicious sources, analyzing the content of linking pages, and monitoring the overall link structure for anomalies. A crucial claim is that effective spam detection requires a multifaceted approach, combining both content-based and link-based analysis. The authors suggest that future research should focus on developing more sophisticated spam detection algorithms that are resistant to adversarial manipulation. While they articulate the problem clearly, the solutions presented remain relatively high level. The paper lacks concrete details on the specific spam detection techniques employed in Google. However, the mere recognition of the problem and the proposed strategies foreshadow the ongoing battle against link spam that would define the evolution of web search. The discussion on handling link spam underscores the importance of considering security and robustness in the design of search algorithms. Section 8, Scaling and Performance Considerations. This section provides further insights into the practical challenges of building a larger-scale web search engine, emphasizing the importance of scalability and performance. The authors discuss the techniques used to optimize the performance of Google, including caching, data compression, and parallel processing. A key claim is that the efficiency of PageRank is crucial for its practical application, allowing it to be computed even for very large graphs. The section details the distributed architecture of Google, highlighting the use of multiple servers to handle the computational load. It asserts that this distributed architecture is both scalable and fault-tolerant, capable of handling the ever-increasing demands of web search. The discussion on scaling and performance considerations reveals the engineering challenges involved in translating theoretical algorithms into real-world systems. It emphasizes the importance of optimizing every aspect of the system, from data storage and retrieval to query processing and result ranking. The successful operation of Google provides empirical evidence for the effectiveness of the scaling and performance techniques described in this section. Section 9, Content Analysis and Indexing. While PageRank is the central focus of the paper, the authors acknowledge the importance of content analysis and indexing in achieving optimal search quality. This section details the techniques used to extract relevant information from web pages and construct an efficient index. The authors describe the process of parsing HTML documents, removing irrelevant tags, and extracting words and links. A significant claim is that accurate parsing and indexing are essential for identifying the key content of a page and establishing its relevance to user queries. The section also discusses the use of stemming and stop word removal to improve the accuracy of search results. Stemming involves reducing words to their root form, while stop word removal involves eliminating common words that have little semantic value. The authors argue that these techniques can help to reduce noise and improve the signal-to-noise ratio in search results. The description of content analysis and indexing techniques highlights the importance of combining link analysis with traditional information retrieval methods. It demonstrates that PageRank is not a standalone solution but rather a complementary component of a comprehensive search engine. Section 10, Query Processing and User Interface. This section briefly describes the process of processing user queries and presenting search results. The authors explain how Google parses user queries, identifies relevant keywords, and retrieves matching documents from the index. A key claim is that the speed and efficiency of query processing are crucial for providing a positive user experience. The section also touches upon the design of the user interface, emphasizing the importance of simplicity and clarity. The authors argue that a clean and intuitive interface can help users to quickly find the information they are seeking. The description of query processing and user interface design provides a glimpse into the user-centric approach that would characterize Google's later development. It underscores the importance of not only providing accurate results but also delivering them in a fast and user-friendly. Section 11, PageRank Variations and Extensions. Although the original PageRank formulation is the central focus, the paper alludes to potential variations and extensions of the algorithm. The authors suggest the possibility of incorporating additional factors into the PageRank calculation, such as the age of a page, its uplit frequency, or its geographical location. A key claim is that PageRank can be adapted and refined to address specific needs and applications. The section also hints at the potential for using PageRank to identify influential individuals or communities within the web. This suggestion foreshadows the later development of social network analysis techniques. The discussion of PageRank variations and extensions highlights the flexibility and adaptability of the algorithm. It demonstrates that PageRank is not a static formula, but rather a framework that can be customized to suit different contexts and objectives. Section 12, Conclusion, Enduring Significance. In conclusion, the anatomy of a large-scale hypertextual web search engine makes a number of significant claims, meticulously detailing the design and implementation of a pioneering web search engine. The authors build their argument by systematically presenting each component of their approach, from the web crawler and indexer to the PageRank algorithm and query processing module. The paper's central claim that link analysis can dramatically improve the relevance and quality of web search results is strongly supported by experimental evidence and comparisons with existing search engines, while the paper acknowledges some limitations, such as the absence of specific sample counterexamples or comprehensive scalability evaluations. Its overall message remains compelling. The subsequent success of Google, built upon the foundations described in this paper, provides further validation of its key claims. The paper's enduring significance lies not only in its technical contributions but also in its articulation of a new paradigm for information retrieval. It demonstrates the power of leveraging the hypertextual structure of the web to organize and access information, paving the way for a new generation of search engines and online applications. It is a testament to the transformative potential of combining academic research with practical engineering to solve real-world problems. The enduring legacy of this seminal work is evident in the continued relevance of link analysis in modern web search, social network analysis, and other information retrieval applications.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.